Howdy, today on Flippin Science we're going to look at finding the charges of silicate and aluminosilicate anions. So science understanding we're going to look at silicon dioxide, silicates and aluminosilicates are important components of rocks and soils. Write the formula of the anion, give them the formula of a silicate or aluminosilicate.
So silicon is very important. It's the second most common element in the Earth's crust and is found combined with oxygen to form silicon tetroxide tetrahedra. Sometimes the silicon dioxide, the ratio depends on what the silicon is joined to, or how many oxygens the silicon is joined to. The silicates are important because they can form a wide variety of shapes, and that leads to different structures in the silicate, and they produce the different rocks that you get. The silicon can also bond with aluminium to produce aluminosilicates, and again, they make up a decent whack in the minerals that are found in the Earth's surface. So what do you need to be able to do? You need to be able to find the charge of the silicate or aluminosilicate ion. There's a couple of ways of doing it. I'll take you through two different ways of finding the charge. The first one is to use the oxidation numbers of the components that make up the silicate or aluminosilicate. Basically, you add those together in the right ratios, and that will give you the charge of the aluminosilicate ion. So we're going to start with albite. So we've got the formula down here of albite. We want to figure out the charge on its aluminosilicate. So what we're going to do is we're just going to focus on the aluminium, silicon and oxygen part of it. So we've got Al Si3O8, and we need to find what the charge is on that. So what we're going to do is we're going to add up the oxidation numbers in the correct ratios, and what will be left over, our number at the end, that will give us our charge. So aluminium is +3, so we've got +3. We've got 3 times the oxidation number of silicon, which is +4. So +3 times 4, and +8 times the oxidation number of oxygen, which is -2. So 8 times -2. And if we add those together, we'll get the charge on the aluminosilicate ion. So we've got +3 +12 -16. So we've got 15 minus 16, and that gives the charge of -1 overall. So the charge on the aluminosilicate ion is -1 there. There's another way of doing this, which is where you just look at any of the metals that you have maybe out the front of the aluminosilicate, or you look at any other ions that you might have at the end. So you might have some hydroxide ions at the end that will have a -1 charge. You might have some metals at the front that will have a positive charge. So in this case, if we look at albite here, we can see out the front there's a sodium ion. So the whole point is the charge in the end has to be neutral. So the sodium ion here has to balance out the charge of the entire aluminosilicate over here. So the charge on sodium is +1, so that means the charge on the aluminosilicate has to be -1. So if we have +1 plus the charge of, in this case, an aluminosilicate, has to equal 0. So our sodium is our +1, so then the charge on the aluminosilicate has to be equal to -1. So our charge over there would be minus, and our charge for the sodium would be plus. So we'll do another example. We'll look at lawsonite. Now again, it's a silicate ion they've said specifically, so we're not going to include the aluminium in our calculation. So the silicate ion there is Si2O7. So we need to find the charge on that. So I'll do the first way over here. Alright, so we've got 2 times the oxidation number of silicon, which is +4. And we're going to add to that 7 times the oxidation number of oxygen, so 7 down here, which is -2. So we've got 2 times +4 is 8. 7 times -2 is 14, so 8 minus 14. 8 minus 14 is -6. Alright, so that gives us our charge on the ion as being -6. We'll try it the second way over here. So I'm looking at the things that are out in front. So I've got a calcium. A calcium has a charge of +2. I've got two aluminiums. Two aluminiums is, each aluminium is +3. And then I've got two hydroxide ions at the end here, and they have a charge of -2. So I've got +2 +6 -2, cancel that off, and I get a charge of +6. Alright, so all the other bits there, they're producing a charge that is +6, so that means the charge on the ion has to be -6. So both ways confirm the same result. So here's another example. We're looking at the aluminosilicate ion in naturalite, so we need to include the aluminium in there. So we get Al2Si3O10. That's the aluminosilicate ion there. So we'll do the first way over here. It's got 2 times the oxidation number of aluminium, which is +3, 3 times the oxidation number of silicon, which is +4, and 10 times the oxidation number of oxygen, which is -2. So we get +6, +12, -20, +6 +12 is 18, 18 -20 is 18 -20 is -2. Alright, do the second way over here. So the only thing that we have to worry about there is the sodiums here. The water here doesn't, that's water of hydration, that doesn't incorporate a charge at all. So the charge on each sodium is +1, so the overall charge on the metals there is +2, so therefore the charge has to be -2. So both of those confirm, so we get a charge on the aluminosilicate ion as being -2. So by showing you this, we can see that the silicate mineral overall has no charge. So the charge on the anion, the silicate or aluminosilicate anion, has to be balanced by metal cations or the hydroxide ions that we saw before. So if you know the charge of the silicate anion and the metal cations that are involved, you can determine the formula of the mineral. So here's an example question. It says the silicate anion in serpentine is SiO10-4. There are hydroxide ion presence in a mole ratio of 8 hydroxides to 1 silicate ion, and the cations present are magnesium ions. Find out the formula of the silicate. So there's a little bit of work involved here. So we'll start with working at the back. So we've got SiO10. Now that has a charge overall of -4, so we'll put that there. For each one of these, we have 8 of these. So we're going to include 8 hydroxides just to see what our overall charge is. Okay, so our overall charge of this stuff over here, we've got -4 and 8 times -1, so -8. So we've got an overall charge of -12. Now that needs to be completely balanced by the cations out the front in this case. Each magnesium ion is +2. So we need to divide out -12 there by 2, and that gives us 6. So we're going to need to have 6 magnesiums out the front. So our overall formula, so we've got our magnesiums there. So our overall formula of the silicate in this case is going to be Mg6 SiO10 OH8. So here's another question. It says the silicate anion in pyrope is SiO4 4-. 3 of those ions are present in the minerals formula. The cations present are magnesium and aluminium. 3 magnesium ions are present. So our question really is how many aluminiums are present. So we need to figure out our overall charge. So we've got 3 times the charge on the aluminosilicate, which is -4. We've got 3 magnesium ions present, so it's 3 times the charge on the magnesium is +2. And overall that's going to equal our X, so that's the charge that we need to balance with the aluminium ions. So we've got 3 times -4, so -12, plus 3 times +2, so that's 6, equals X. So our charge that's -12 plus 6, so -6. Our charge that we need to find using the aluminium ions is +6 to balance that out. If there's a charge of +3 for each one, so divide that by 3, that means that we're going to have 2 aluminium ions. So the overall formula of the silicate mineral We're going to have our Mg, we've got 3 of those. Our aluminium, we've got 2 of those, and then our silicate, Si04, and we're told 3 of those are present, so put that in brackets, put the 3 at the end. So today we looked at how to find the formula of a silicate or aluminosilicate anion given specific information. That's it for Flipping Science today. See ya.